Hi, my name is Ann Vreivik. I'm the Graduate Program Director here at Mount Mary University for Food Science. You've all done these experiments and you've all seen how sugar dissolves in water. So I have here a beaker of water and just a tablespoon of sugar. You pour it in, and you don't even need to put all of it in, just a little bit. Shake it up a little bit. You can see that the crystals will start to disappear over time. That's solubility of like dissolves like. We've all explained that before. But the interesting thing about it is then adding the component of polarity. So we have two polar substances that actually have a chemical attraction between them, which causes the sugar to dissolve. I also have here two nonpolar substances. I have just a regular vegetable oil. I'm going to pour that in. And coconut oil. Slightly different in color. Both of these are nonpolar. Again, like dissolves like. So if I mix it up, you can see that there's no separation between the two different oils. So I have two fat-soluble or two lipid substances that dissolve in each other, and I have two polar substances that dissolve in each other. Of course, we all know the experiment of oil and vinegar, and I'm just going to demonstrate that real quickly as well. So here again is just our regular oil. I'm going to pour that in. And I have vinegar here, and I'm using a darker color vinegar just so that the students can see it better. And when we put them together, just like a regular salad dressing, mix them up. It seems to mix for a little bit, but as it sets, you can see that the oil separates from the vinegar. We now have a polar substance, which is the vinegar, and a nonpolar, which is the oil, and they do not mix. Like does not dissolve like in this particular situation. So you have a separation of oil and vinegar, and this shows that these are not soluble. So we've all done these experiments. Students have all seen these, they all understand these, and yes, it does involve food, but let's make it a little bit more fun for students to see and to understand what solubility is all about. So I have here gumballs and chocolate. And you can use any sort of gum, Hershey's chocolate, just because everybody's so familiar with that. So this is Lexie. Lexie was in my food science class last semester. So Lexie, are you ready to try an experiment?
Yep.
All right. I am going to have you chew up a couple of pieces of gum. Okay? We'll do 3 because it's kind of nice to have. So try to get all of the flavor and the sugar out. Of course, it's yummy. And when you feel like some of the flavor has started to disappear and you're left with just the gum, I'm going to have you taste a bit of chocolate as well. Okay? So you're going to put the chocolate in your mouth, try to mix the two on your tongue, and tell us what is going on in your mouth. Okay? All right. So you just need about a half a piece. So mix them together. What's happening?
I feel like getting smaller.
It's getting smaller. Is it getting softer?
Mm-hmm.
Is it still there?
A little piece.
Little piece?
Mm-hmm. But most of it's gone.
Yeah, most of it's gone. Mm-hmm. So what do you think happened?
I think the chocolate dissolved the gum.
It did, yeah. So chocolate, of course, we know as being mostly fat. That's why when we're on a diet, we don't eat much chocolate, right? And the polymer that food scientists have used to make gum is one that is also fat soluble. So if you get rid of all of the flavoring and the coloring, which are water soluble first, leave behind the gum polymer behind, when you put these together, they dissolve in your mouth. So you've just done the same experiment, except that it's not in a beaker. Now the student gets an opportunity to actually taste it and feel it, and there's a much more in-depth understanding of the scientific principle when there's more of the senses involved. Let's try another way of looking at this. So, you want to take a break and get your mouth washed out, or are you good?
I'm good.
You swallowed it?
Yeah.
Good. Okay. So we're going to start again. Take another couple of pieces of gum. Okay. and chew that up. We're gonna do the same thing. Try to get as much of the flavor out as you can. Okay? All right. So now what I'm gonna have you do is spit it in your hand. It's okay to get messy in science, right? So I'm gonna have you take just dip your finger in there and take about a quarter of that pat of butter. There you go. And I'm gonna have you mix it in there and stretch it out good and mix it in, get messy. There it is. Now, talk to me a little bit about what's changing to the gum as you're doing this.
So the texture is definitely changing. It's getting a lot softer like it was in my mouth with the chocolate. It's starting to get more separated.
Yeah, it's not stretching anymore, is it? Right? So we're getting the same effect here in your fingers. The butter is also mostly fat, and it too is dissolving the polymer of the gum. And you're now experiencing the same idea of solubility, fat dissolving fat, only now it's in your fingers. Right, so just like what happened in your mouth where the chocolate dissolved the gum, now we have butter dissolving the gum. They're both fat, and again, the polymer is nonpolar, the butter is a fat. Together, they dissolve in each other. And so there you go. You're doing exactly what happened in your mouth, but you're getting a little bit of a different experience. In one way, we tasted it, and the other way, you're actually feeling it and seeing it. Pretty cool, huh?
Yeah.
Yeah.